Hello, this is Paul from Foresight Tech. In this lecture, I'm going to introduce the substitution for definite integral. The last topic we introduced the substitution for indefinite integral, right? Almost similar, almost the same, a little bit of difference. Let's see the difference. Okay, we look at this integration. First, the integration is definite, right, from A to B. Here is the same, okay, the same as before. And look at the substitution. After the substitution is here, okay, so this is substitution. This is a substitution. Okay, after we substitute the gx use u, so of course this is fu, and this whole term is du. One difference, look at the limits, the lower limits and the upper limits both changed, right? Changed to where? Changed to the function of g, which is u. Why? Because the integral variable changed to u. Integral variable changed to u, the limits we have to change to u. The original limit is for x. The new limit is for u. Okay, this is the major difference. And a little bit one more difference, which is look at it. And the inner function gx is differentiable and also continuous and continuous. And for substitution for indefinite integrals, we don't need the continuous. Okay, so there's a little bit of difference. And let's see proof. We have to use the results from the last topic, which means the substitution for indefinite integral. Look at the left. We use fundamental. This is equal what? This is the antiderivative from the last substitution rule. Okay, and the difference is from A to B. So be careful. This A B is for x, right? Okay, this capital F is the antiderivative of lowercase f, and then we look at it. If we substitute the gx use u, so this function will go to fu. Remember, now the difference A to B should be changed to what? Changed to u. Okay, what is u? Okay, when x equals a, u is ga. When x equals b, u should be gb, right? Okay, we look at this one. This one exactly is the right side. Why? Because capital F is the antiderivative of lowercase f. And use the fundamental. This is the fundamental goes to the right. Okay, so not difficult, right? So we look at one more is results for symmetry. This is very special, and later I will have an example to show you how to use this. We look at this. If the integral interval is symmetry about the origin, negative a to a, okay, this is symmetry. And the fx, if f is odd function, and then the integral goes to 0, okay, it means what? It means you don't need to do any integration, do any calculation. I will show you why. The second, if f is even, this time is not a 0, but double half. I will give a very rough, use the graph, and later the strict proof will given later. So I just draw a graph. F is odd. I simply say this is a Cartesian system. I take a sign. Okay, remember this. Okay, it's odd, right? If it's odd, look at the integral from negative a to a. It's easy to see by symmetry. And this is negative, and this is positive. The same absolute value of the area, of course, that's equal to 0, right? The same for what is even. If it's even, I give it like a cosine function. Okay, probably you can think about this. Like this. It's an even function, symmetrical about the y, right? Odd is symmetrical about the origin. Symmetrical about the y, you can think about it. See, the total area, of course, the left side, the area of the left equal the area of the right, which means the total is double of the right, right? It's double of the right. So this is definitely true. but it's not an exact proof. I will going to show you what is exact proof at the end. Okay, after a few examples. Now, let's going to do this application. Okay, so how to use the substitution for definite integral. This is very, very important. Keep in mind, don't miss. This is very, very important. Look at the first. And the first example is like this. We're going to integrate from 0 to 1. Of course, do substitution. Well, how to do? We have to do substitution. I put it to here. Okay. Do substitution. This is u, right? Okay, up here. So I set up u equals 3t minus 1. And then I will going to solve for dt, right? So du equals 3 times dt. And then I will easily resolve dt equals 1/3 times du. Remember, this is for substitution. Okay. And so we said is the similar as we did for indefinite integral before. Okay, both of them we need to substitution. But one more, do you remember the limits? We have to change the limits to u this time. The original limit is for t. Now the new, after we substitution, the new limit should be equals to u. So what is the new u up here? Is this. Okay, I simply say, what is 0? Is t equals 0, right? When t equals 0, what is u? T equals 0, 0 minus 1 is negative 1, right? So we find that u equals negative 1. That means the lower limit we need to change to negative 1. Okay, how about the upper limit? The same. Take t equals 1. Plug into the substitution. T equals 1, 3 minus 1 is 2. So we have a u equals 2. The upper limit goes to 2. See, this is something new from the last topic. Something new. Okay, don't miss this step. Okay, and then now I will going to do substitution. Is this after we substitute the lower limit goes to the negative 1, the upper limit goes to 2, and then this goes to u 50 power. What is dt is there? Okay, at times 1/3 du, right? So almost. And now do calculation 1/3 factor out. So it's 1/3 integral from negative 1 to 2 u raised to the 50th power. Now everything is talking about the u, right? Okay, so just do calculation directly use u. So we use the fundamental. What is the and that value we know because this is a power function. So I will do this. What's that? So this will goes to how many? I put all the steps. Okay, so this is 1/3, and this is better 1/3. I put this together. Okay, you know it's no difference. 1/3 put this together. So what is this? Think is times 1 out of 50, right? Times u raised to the 51st power, and I put these both together. Remember, this is the antidivisible, one antidivisible, but the limit, the difference is from negative 1 to 2. Okay, so this is the fundamental, and this is the substitution, right? This is substitution. Okay, and this is fundamental. Okay, fundamental theory. Now you know, just do calculation. Do calculation. So okay, so I will going to do all the calculations. 3 times 50 is 1 out of 150, right? Times u raised to the 51st power. Go to negative 1 to 2. I will complete. Plug 2 in is 1 out of 50 times 2 raised to the 51st power, and then minus negative 1 plug in. So 150 times negative 1 raised to the 51st power, So negative 1 raised to 51's power is negative 1, right? So this goes to plus. Therefore, we put it then together. What do we get? So we will get this 2 raised to the 51's power plus 1 divided by 150. This is the exact number. Okay, it's good. This is the first step. See, most important is there, right? This is one more than the substitution for indefinite. Don't miss this step. Okay, another example. We look at this. So how to do substitution? So probably you will think which part is the most difficult. Which part is, what does this mean? This means 1 over x times ln times dx. Okay, dx. So you can going to see which part is complicated. This part is the most complicated one, right? So we will do this substitution. We will do u equal that. Okay, I'll put here, see what will happen. So we set up u equals ln x. So we look at what is du. This take divided 1 out of x, dx, right? And then we can solve. Okay, it's already good. So can you see? And if we separate it into two parts, 1 over x times dx. See, that's 1 over x times dx already. Another is ln x. So that's very good, right? Means we already have this. Okay, and both of them we need. Remember this. This is for substitution. But how about the limits? So now it's the same. I'll put the limits here. You know the step, right? Set up x equals e. That means when x equals e, x equals e, what is u? U equals ln at e, which is 1. The same when x equals e squared. E squared. You know u is ln e raised to the second power. One of these is 2. Okay, and this is the new limit we need. We put it here, and both of the box we need, right? So we are plugging there. So the first step directed to substitution. The new limit is 1 to 2, 1 to 2. So you can see, right? This is what? This is u, and that is du. So what do we have? So 1 over u, right? And then du. Is this correct? Yes, definitely. Okay. This step is substitute. Is substitution. Okay. Substitution step. And then now you know what this. This is a reciprocal function. We know the antiderivative of reciprocal, right? Because we have basic formulas. So now I just use the basic formula. This is ln. It's ln. Remember we have absolute value, right? Okay, good. And this is one antiderivative, and then focus on what? Focus on 1 to 2. Okay, that's all we need. This is a fundamental. And this is use the fundamental. And then we just do calculation. Of course, plug in 2 is ln, absolute value of 2 is dr2 minus ln at 1. Okay, ln at 1 is 0, so you can simplify a little, is get ln at 2. Okay, so this is the results. Take a look at it. If we have the substitution tool, this is easy to do calculation, right? Okay, one more. Look at this. Evaluate the definite integral for this. Looks complicated, but don't worry. Okay, but don't worry. How to do substitute? So can we substitute the sign? If we substitute the sign equals cosine square, we have to use the Pythagorean 1 minus some square, right? That's a little bit complicated. It's better to do this substitute at the bottom cosine t. If we substitute the cosine t, use u, much easy, and then the denominator goes to u square. Don't worry about the sine t. The later we can look at it. So we substitute this is u, means we do u is cosine square at t, see, and then we're going to find out what is du is 2 times cosine t, right? And this take a derivative. This is a composite function. So the inner is cosine t. Okay, the inner is cosine t. So this is the outer, and then times the inner. What is the inner? Okay. I think this is too complicated. If we do this, you will get, we never reach to the sine t. So we will get, we have to change. Okay, we have to change. This is u equals cosine t, right? See, if we do this, we find something wrong. Okay, we find something wrong, very complicated. Keep in mind that don't do this. Cosine t. Okay, if we do u equals cosine t, du is easy. Du equals what? Du equals negative sine t. Okay, negative sine t. Okay, and then dt, right? Times dt. Why we do this? If we do cosine t, this goes to u squares. They are simple, and then sine t times t, sine t times t, we can directly find the link to du. That's much easier. See, like a link to du is what? Is sine t times dt equals negative du, right? This is what we need. Okay, so you look at it, the first we need, and the second we need. Okay, so you can put the sine t and the dt together. Sine t dt together is negative du. Good. So everything is simple. But one more limit. Okay, I put the limits here. Okay, when t equals 0, when t equals 0, what is u? So u equals cosine at 0, which is 1, right? Okay, good. And another is when t equals pi over 4. So what is u? U cosine pi over 4 is square root of 2 over 2. Okay, 45 degrees. So you need to remember this, and then we plug in. This part is for the limit, and then we have almost everything, right? We do calculation now. I do calculation in here. So this time we do substitution. Substitute the limits goes to 1 to square root of 2 over 2. The integral function, this is u square. Okay, the bottom is u square. Good, u square put here. And at the top, sine t times dt, well, okay, here. It's better I put it parenthesis negative du. Okay, negative du, right? Okay, so this is a substitution. And then what do we need to do? Negative factor out, so negative 1 square root of 2 over 2. So the 1 over u square, this is a power, negative power, right? So it's better to do this, negative 2 and then du. Okay, what do we have? We have a negative, right? So we have a negative. So we have a negative, and then we need to do calculation. So this is the power. Okay, so we need to do what? We need to find the power. Okay, is negative. So what is? We're going to do, this is u raised to the negative 1's power plus 1, and then divided by what? Divided by negative 1, which is negative 1 here. See, and from 1 to square root of 2 over 2. I simplify a little. These negatives still can put in, okay, because this is the parenthesis. Negative goes to positive. See, we can see u inverse. So probably you can do this. I can do the inverse. I change it to 1 over u. Okay, look at a little bit better. So 1 to square root of 2 over 2. And then now is plug this in, is switch the order. So 1 over square root of 2 over 2 minus 1 plug in is 1. Okay, simplify this. This is times 2, so goes to 2 over square root of 2 times the square root of 2, both numerator denominator. What do we get? We get square root of 2. Okay, and then minus 1. This is the result. Okay, we look at one more here. So how about this? This done. Looks very complicated. If we do substitution, look at this one. If we do substitution of sine, use u, you cannot get x. If we substitute the x with the first power, because you cannot get it simple for sine x, you never. Okay, so this we never go to substitution to simplify the integral function. Okay, in the future we will have another product. Okay, we call the integration by parts. Okay, so we can do that method, but now we don't have. However, we have a feature here. So what this? This is from negative a to a, which means a symmetry about the origin, right? Okay, so do you remember we have a result? We look at this function. If this is a good function, has a good symmetry, either even or odd, we have some issue, right? Okay, we need to look at this. If I say this is fx, okay, my conclusion, this is even, this is odd, so this is odd function. Remember, y is odd. Okay, so I prove here y is odd because here f inverse f at negative x equals what? I'm going to do this negative x raised to the first power times sine at negative x, and then this goes to x with the first power, this goes to inverse, right, times this goes to negative sine x. Okay, and this negative can plug, of course, negative x to the first power times the sine is negative fx. What does this mean? This means f. Okay, this means f really is odd. If it's odd, you remember this, right? You remember the graph I drew, odd like this. See, and this is a negative, and this is a positive. So the integration goes to 0, right? So we have this symmetry. Okay, so the original. Okay, so the original negative pi over 3 to pi over 3 fx dx equals 0. You don't need to do any calculation. Okay, it's already. So this is very special, right? Okay, good. Now the last step, I'm going to just do complete proof for what is the symmetry. These are results we just used, right? In the last example, f is odd, so this is the symmetry interval, so that's 0. Okay, if f is even, okay, the left and the right are the same, so it's double the right. How do you completely prove this? So let's look at what we need is the substitution. Okay, so I'm going to substitute. You know this negative a to a, which means negative a to 0 plus 0 to a, right? We look at the left side. We look at the left. Okay, look at the left is this. I will put it here. Negative a to 0. We look at the left half. Okay, the left part. What do we have? And then so wait a little. Okay, good. It's a little bit better. So we look at the left. This is the left. Okay. What do we need to do? We need to use this f is odd. Okay. F is odd. We can find what? We can find f negative x equals negative fx. Okay, this means what? This means see f at x, f at x, f at x, so we can roll into negative f at a negative x, okay? And then this block inside we can do this. So this time negative a 0. This goes to negative f. If I put the negative to here, it's the same. Okay, f at a negative x dx, right? Okay, I mean this one is the first step we use this. And then now, what kind of substitution we can use? Now you know. Okay, we learned that this negative x is the complicated. We do this substitution. Okay, we can substitute. We use this. We use a u equals negative x. Of course, you can find the dx easy, right? Du equals negative dx, so dx equals negative du. Okay, and good. So this is the substitution, but we need to change the limits. Don't miss the limits. Okay, so for the limits, we need to do this. We need to look at x equals the lower limit is negative a. What is u? U equals a, right? So this time u equals a. When x equals the 0, what is u? U is also negative 0 is 0. Okay, so this is the limits we need. See, I put it here, this box we need for the limits. And then I just plug in. What do we have? So this time we have negative, negative a is a, so this is goes to a. 0 goes to 0, so that's 0. Good. So here is what? Here is f at u, right? Good. What is dx? Dx is next, so I times parenthesis negative du. See, this is substitution. Okay, and negative goes to positive. I was going to make a positive first. 0 f u du. So everything goes to positive. I will do one more time. Do you remember we said when we do definite integral, the variable does not matter, right? So you can directly change u to x. If I change u to x, is this is a0. F I change it to x. You can think about why we can directly change, or you can say is do this u equals x. Do this substitution. U equals x, so everything goes to x. The limits does not change because the limits for x equal the limits for u. You can say this is a substitute. Or we just simply say change the variable to any variable, does not matter, okay, for definite integral. Okay, so what is? Do you remember we have properly changed the limits, change the order of the limits? What do we get? We get a negative. We get a negative 0 to a f x dx. Okay, good. And we have this means what? Okay, see, and this function cut into the left part and the right part. The left part equals the negative of the right part. If we put that together, is 0. Alright, or I put them together exactly. See, the original one is this negative a to a f x dx. We can change it to two parts, negative a to 0 f x dx plus 0 to a f x dx. See, and the first step with the left part goes to negative this. Negative this plus this goes to 0, right? That's equals 0, definitely. So that's true. Okay, and then is the almost the similar. Okay, for this double, I will go much faster now. Okay, I will go much faster now. It's the same. We look at the left part. We look at the left half f x dx. What do we get? It's even. Of course, I will going to use the even. The even means f x equals negative. Sorry. So I need to do this f negative x. Okay, there's no negative there. Keep in mind. So this is even f negative x equals f at x. So I plug into there. we will have this. This integral negative a to 0 f at a negative x and dx. Okay, and then I can do substitute, right? So this we can substitute. We use this u equals negative x. The same we have dx equals negative du. The first substitute, and then we look at the limit. So the limit is the same. Okay, when x equals negative a, u equals a. When x equals 0, u equals 0. So we find that the limit, the new limit is here. We need, and then just plug in. So equals what? This equals a, right? A to 0. F at u. Okay, dx is negative du. Okay, negative plug out is negative a to 0 f u and du. The same. Okay, to substitute this use no, I will go do this. I will switch the order of the limits first. So this negative goes to positive, so it goes to this 0 to a f u and du, and then it's the same, right? So we can do this. So we can do 0 a f x dx, and then here is the substitute, right? You can do substitution. Substitute in this way, u equals x. Okay, you see, it means just change the variable. Now you can see what we have. Negative a to a f x dx is equal to two parts. Negative a to 0 f x dx plus 0 to a f x dx. This part equals this part, so we have double 0 a f x and dx. Okay, that's all. Thank you.